A very good afternoon to everyone. I am Rosalie Andico, Senior Solutions Architect at AWS, and I welcome you to our session on Achieve Rapid Insights with a Modern Data Architecture on AWS. Joining me later is the Technical Product Manager of MSD, or also called MERC. She will be sharing with us their modernized data and analytics platform where they created a global and regional data hubs for their users across geographies without duplicating data in every region. So she's Deepika Punipali, and she will be joining me later. I will kickstart my presentation with concept of a modern data architecture on AWS and show examples of AWS services to help democratize the analytics experience. Then I will also show a demo of Amazon Redshift data sharing. Deepika will then talk to us about their cloud data hub, beginning with business objectives and the data hub capabilities and use cases and the business outcomes. Why a modern data architecture in AWS? Managing on-premise data and analytics systems can be expensive, right? It's very difficult to scale, very difficult to manage. And often, it lacks the agility to keep up with your business innovation. Many customers, they spend significant amount of resources just to continue to manage these traditional on-premise data and analytics systems. Now, migrating your workloads to the cloud will free up all these valuable resources, both financial and staff resources, so that your business can focus to what's important, like high-value tasks such as innovation or creating new services. There's actually a study on this of enterprises who have moved to AWS. They achieved at least, or on the average, a 30% cost savings. And the same study also projects that IT infrastructure teams are 62% more efficient, and application developers can be 25% more productive. Now, many organizations around the world, such as MSD, who will be sharing today, have experienced improved business outcomes. So stay tuned until the end of the presentation. Now, how can you implement a modern data architecture on AWS that will democratize the analytics experience, making it available, accessible, and affordable for all the users across geographies without duplicating data in every region while achieving an SLA. Now, many organizations today, they face challenges in data silos, people silos, and business barriers that make it difficult for them to derive actionable insights from data. But with a modern data architecture on AWS, you can easily overcome all these challenges. Now, how do you do that? You need an end-to-end data solution that will allow you to store, to access, to analyze, and to visualize and predict. You will need a storage for your data. Or this can be a data lake that will aggregate or consolidate all your data sources. Then you will need tools for data movement. You will also need a database where you can create data products and store data that are analytics ready. You will need analytics and visualization tools and AI ML for insights and machine learning, and you will need a security and governance as solution so that data can become accessible to all levels of the organization. And finally, you will need a workflow and orchestration framework. An enabling technology that will allow you to democratize analytics in your organization is Amazon Redshift data sharing, where you have data producers sharing data across all your data consumers. This architecture will allow you to create data products and at the same time enable live access to your data. Live access to data means that all the users in your consumer cluster sees the most up-to-date and the most consistent view of information. Amazon Redshift sharing also allows you to share data at different levels. You can share data at database level, you can share data at the schema level, at the views level, at the table level. And it is very straightforward to configure. I have here a demo to show you. It's going to be quick. Here's hoping we can all follow. This demo will show you that a data analyst querying from the consumer cluster can create insights and join a local order table with a globally shared customer table. And then I will show a second demo to show live data sharing where we insert new data into the customer table, and your data analyst at the consumer cluster will be able to see the most up-to-date information. So in this demo, I have launched two Amazon Redshift RA3 clusters, one in Oregon serving as our data producer, and the other one is in Singapore serving as our data consumer. Both of these clusters were created in the same account, although different regions. We're going to use Query Editor V2 to navigate our data objects in our cluster. This shows a tree-view panel where you can view or you can see database objects such as the database, the schema, the tables, the views, functions, and stored procedure. Now in this demo, the producer cluster hosts our reference data or our lookup data. Example would be the customer table, the region table, and the supplier table. And our consumer cluster hosts the regional transactions on orders. Now to configure data sharing, the first step is for us to identify the consumer namespace. This is the unique global ID that's automatically created in your Redshift cluster. You can also view this global ID from the console. In the producer cluster, we can then run a few commands to create the data share. First, you can create a data share, and then you can add database objects into the data share, and then grant access to the consumer cluster. Then we can use the show data shares command in order to check if the data shares have been created. And in this demo, we can see that customer DS data share is created as an outbound share from the producer cluster. And in the consumer cluster, we can also check using the same command to see if that data share is visible. So you see that customer DS is visible as an inbound share. Now that we have created our data shares, we can then create a local database on the shared data. Of course, here we will use the producer namespace. And then we can use the tree view panel to check our database is created. In this demo, it's customer DB that we created on customer DS share. So you can see the customer table. Now we are ready to query, but before that, let's try to do a count just to validate our data load both from the producer and the consumer cluster. Here we are seeing 15 million rows for both producer and consumer, which is what we want to see. Then your data analyst can start the query. He can then join your local order table and your globally shared customer table and derive insights like, for example, find a total sale price based on market segment and order priority. Now, what is actually happening here is that the queries that your users are doing on the consumer cluster, they run on the consumer cluster but read data from your RA3 managed storage of the producer cluster. So no impact on the compute there. Now, the second demo is live sharing, where we insert new customer data into the global customer table. Here we can see with a count that the insert reflected and is successful. And then from the consumer cluster, we can also check that we have there the most up-to-date information of the new customer. And we can see from the select count that the count incremented. All right, so this means that data was shared live as it was updated from the consumer cluster. That's the end of our demo. And now I would like to welcome Deepika Punipalli on stage.
Hello everyone, very good afternoon. I'm here today to share with you the HHI Data Hub modern data architecture to achieve rapid insights. It's definitely crucial for every business decision across the industries. I am Deepika Punipalli, Technical Product Manager in MSD Singapore. I am responsible for Human Health Insights Engine, HHI Data Hub as a product that developed the solutions to onboard the data and build the standard integration pipelines from different application systems such as CRM, digital, and other third-party systems. Before we jump into today's topic, let me share a little bit about our company. For more than a century, MSD has been inventing to solve some of the greatest challenges to the people's health and well-being around the world. MSD is a trademark of Merck & Company, headquartered in Rahway, New Jersey, United States. Today, MSD is a global healthcare leader and a premier research-intensive biopharmaceutical company to provide the leading innovative health solutions for today and for the future. Through our wide range of products in oncology, vaccines, prescription medicines, biological therapies, and animal health products, we work with our customers and operate in more than 140 countries to deliver our innovative solutions. Our purpose is to use the power of leading-edge science to save and improve the lives around the world. Now let's understand the key business objectives to build the HHI data platform. Human health operates across multiple regions as the commercial arm of MSD. In order to meet the needs of various user personas such as data scientists, data analysts, business users, and application users, a centralized platform is highly essential. This platform acts as a single point of entry for all our data consumers, enabling the self-service analytics to drive internal customer experience, and to enable the advanced analytics use cases that enhances the revenue, reduces the cost, and improve the customer experience. By providing the optimized data ecosystem that improves the time to market and enable the timely launch of our new products and support the data-driven decisions. Additionally, data security and governance to meet the compliance and regulatory requirements that are more stringent when dealing with the sensitive data sets. Now let's understand the HHI Data Hub setup. HHI Data Platform has been on a cloud modernization journey for past couple of years. HHI Data Hub is a global solution supporting over 70 markets. In European region, we caters to 45 markets, in Latin America region to 15 markets, and in Asia Pac to 13 markets. The physical infrastructure is also segregated by each region. We have the data hubs located in Singapore, Ireland, and North Virginia AWS region, together with some dedicated data hubs for the selected markets. All of the markets within the same region share the same data hub. As you see here, in the former state of integration pattern, both global and regional data sources are provisioned into the regional data hubs to fulfill our regional use cases, together with the data available locally in the respective regions. This architecture pattern included over 70 pipelines, which increases the operational inefficiencies and additional administration overhead. And this also increased the backlog and delays in time to market. To streamline this situation, we have introduced Core Data Hub, which is called Global Data Hub, which does the global integration from our global data sources and also supporting our global use cases. This is the primary objective that required a sharing mechanism between different Redshift cluster within a same region and cross region to and from the same AWS account and the cross AWS account. So to achieve this global and regional integration pattern, we have primarily leveraged a built-in feature of Amazon Redshift data sharing. Together with data sharing, we have also used other AWS services such as AWS Glue for all our ETL requirements and Amazon S3 for storage and backbone and other supporting services such as Lambda, SQS, SNS and others. So, to all the global data sources that are ingested into the Global Data Hub, which acts as our producer cluster. From there, the data is securely shared with the multiple consumer clusters across the AWS regions. This modernized architecture has streamlined over 70 pipelines into one single pipeline, which is highly scalable and cost effective. Upon onboarding the data into the global hub, the data is immediately available for all the regional hubs. As a result, it significantly improved the time to market. Now, Amazon Redshift data sharing also allowed us to do the in-place data sharing. We have used it for the enhanced data management for sensitive and common data sets. To meet the compliance with regulation, we segregate the sensitive data by creating a published metadata schemas governed by the security policies for access control. These security policies are configured within the global access layer, which we call as GAL layer. Sensitive data sets in itself are segregated into a separate data share for increased security and isolation and is shared live from one cluster to the multiple consumer clusters by using the data share. This approach allowed the data owners of the sensitive data sets to restrict and govern access to the authorized users while prohibiting any physical copies of the data outside their environment. Here is our approach for configure data sharing and segregation. As you see here, the sample data share is being shared with same account cluster as well as cross account AWS cluster. For the data share within the same account, we specify the consumer cluster namespace, and for the cross account data sharing, the access is controlled on both producer and consumer AWS accounts. On the producer end, we specify the consumer cluster AWS account to allow the access to the data share. On the consumer end, the access to a specific consumer cluster is managed by using the namespace associations to grant access to a particular consumer cluster within that consumer account. As the consumer cluster administrator associates the data share to a particular data consumer, the status of the data share becomes active on the producer side. Now you may be thinking that Redshift, we are using this Redshift data sharing at a very large scale, how is the performance, right? Definitely in terms of the performance, same region data sharing is much faster than the cross-region data sharing due to the network latency. Now as we are discussing more onto the Redshift data sharing, some of you might be thinking, how are we doing the data ingestion into the data hub? Yes, we are using a data ingestion framework to ingest the data into the global data hub, and it is a cloud native repeatable pattern that we have used across both global and regional data hubs. This data ingestion framework was built for simplifying the creation and deployment of data pipelines by using the input configuration via YAML template. This template contains all the actions that we need to perform on the data set at one single place, making it expandable and scalable to the multi-dimensional data sets. This modernized data ingestion framework uses AWS Glue as a serverless on-demand ETL solution, which removed the overhead of managing the infrastructure, and at the same time, it increased the data discoverability by providing the metadata cataloging. As you see the detailed approach here, the data ingestion framework generates a glue job that is used to acquire the data from the respective data sources into the S3 data lake. And we also use Airflow as a tool for scheduling and orchestration. And if some of you may not be aware of, Airflow is a cloud-based scheduling tool for all the workloads running in the cloud. Within the S3 data lake, the data is partitioned as the base data and curated data. In the base data, the data is stored in the form of raw data, and in the curated data, the data is stored in the Parquet format enabled with the glue data cataloging. From the S3 data lake, the data is exposed to the Redshift cluster by using Redshift Spectrum by enabling the external schemas. From the external schemas, the data will be accessed and processed further for the change data capture and historization before the final data is available in the Redshift cluster. We also leverage AWS Glue to perform the change data capture and identify the record set and allow us to sync only the changes from the S3 data lake into the Redshift. Once we load the data physically into the Redshift cluster, we will then leverage the Amazon Redshift data sharing to provision access to the regional clusters, and from there, the end users directly get access to the data via the data share or any of our business intelligence tool for generating the reports or dashboards. We also apply the security at the consumer cluster to provision the authorized access to standard or sensitive data sets. Now, with the combination of AWS services, we have also created a framework that performs the change data capture and historization. This framework is also a configuration-driven framework which provides the ability to load the data from S3 data lake into the Redshift after identifying the change records. This framework allowed us to perform several operations such as SED type 2 for the change data capture and historization, and full load for the bulk transactional data loads, and full refresh for the data sets that provide the full data set each time. All of these operations are configured via YAML template and uploaded into the Airflow server. Besides the data ingestion via Redshift Spectrum, we also use AWS Glue to perform the change data capture, which allowed us to sync only the changes from the S3 data lake into the Redshift cluster. So now as we provision the data to our regional clusters via data share, we not only provide access to the end users, but we also use data share as a source to further transform and prepare ready-to analytics data sets for our BI and self-service analytics. To achieve this solution, we have used Matillion as the ELT tool enabled with the queuing mechanism that gets queued by using AWS Lambda and SQS. As the Matillion reads from the queue and push the transformations down to the Redshift cluster, all these transformations are stored within the S3 in the form of config and SQL files. Once the actual query gets executed, it then reads the data from the data share as a source and then transform and link it to the master data available in the respective regions and transform into the target data structures. Here is the sample workload that is reading the data from the data share as source and transform it into the target structure. As the Matillion submit the workload, it hits to the consumer cluster, and from the consumer cluster, it hits to the producer cluster to read and transform the data into the target data structure. Now, as we talk about our technical solution, I would like to share some use cases that were realized by using the data available in the Redshift cluster. On the left side, we have an Amazon SageMaker model that was built, trained, and deployed to analyze the customer volume pricing sensitivity and provide the optimum pricing recommendations. This Amazon SageMaker model allowed the market to increase the average sales price by 10%, putting the market on the top 5 in terms of the absolute growth for the year. And on the right side, we have an engagement dashboard that showcased the HCP digital engagement via different channels and the type of the content more frequently used, and the yearly aggregated data by product. All of these insights allowed the market to provide the best personalized customer experience and increase the digital engagement with the right content and at the right time. Not only this, with the modernization of our data hub into a fully cloud-native architecture on AWS platform has unlocked a significant business benefits and outcomes. These includes increased efficiency and end-to-end data processing by 45%. We have achieved it by modernizing our pipelines and leveraging the reusable frameworks with increased data transparency. And we also improved the collaboration by avoiding the data silos and fostered the reusability of the data sets across the business domains. As of now, we have deployed over 1,000 pipelines globally. And we also reduced the cost of infrastructure and operations by 50% year on year. We have achieved this by using the cloud-native tech stack and eliminating the need to maintain the underlying infrastructure, and at the same time, we have also decommissioned the legacy infrastructure, including some of the licensing cost. We also achieved a scalable data ecosystem, and this enables our markets to refactor their local warehouses and marts onto the HHI data platform to fulfill the emerging demand from the markets and enable the emerging demand and fulfill the use cases. And we also reduce the time to market by onboarding the data sets from weeks to days and provide the seamless availability of the latest data set to all our data community. We also supported the business to meet the GDPR regulatory and compliance requirements and avoid any data breaches by automated access provisioning. All of these benefits have enabled us and expedite and realize over 500 use cases with the wealth of the data available in the HHI data hub in the form of raw data, curated data, analytics-ready data sets, together with the end-to-end data lineage. Just to name some of that include persona segmentation, market share analysis, marketing mix modeling, and many others. All of this has a direct impact on our top line, bottom line, and the customer experience. Thank you all for your time. I will hand it over back to Rosalie.
Thank you very much, Deepika, for sharing those really impressive numbers right there. Don't you agree? What a fantastic business outcome with the modern data architecture on AWS. So this afternoon, ladies and gentlemen, you've heard from MSD how they used Amazon Redshift to build their data hubs that spans across different regions, how they have modernized their legacy ETL workload using AWS Glue and other AWS supporting services, how they have created a reusable and scalable pattern for data ingestion that supports change data capture and historization. Now, these are real-world examples of what you can build on AWS to quickly connect to your data. Now, as proven by the experience of MSD at AWS, we have the broadest portfolio of analytics as solution so that you can select the right tool for the right job with the best price performance at scale. And in AWS, all our services are secure and are reliable to protect your data. Now, if you're curious on how to get started, you can check out skillbuilder.aws, where you can have access to a lot of free content, over 600 free content, and you can also access premium content with a subscription. That's all for today. Thank you very much for joining us, and please don't forget to fill up the survey.